Sorry for not being able to attend the last meeting. So I'm going to start. I'm going to go straight into it. So the first topic was JSON. So what exactly is JSON or JSON? Well, it stands for JavaScript Object Notation. It's a lightweight format for storing and transporting data. So you can think of JSON as a format that the server and the client used to interact with each other or used to send data to one another in a kind of lightweight format. So it was used or is often used when data is sent from a server to a web page or to another application, whether it be a mobile application or something. So, well, why JSON in the first place? Like I said, it was used for data interchanging, now sending data across the server and client. Um, an example of where this is used is web services response. In the That's responses from the server. So in the old days, XML was used for primarily transporting data from client to the server. But since JSON appeared, it has been a preferred format because it's much more lightweight. So there are others out there. There's XML, but JSON is what is preferred these days. So the alternative to JSON, which is XML, YAML, Protobuf, Avro, and OData. So these are alternatives to JSON or considered as JSON competitors. So JSON has a couple of data types. Um, I have a JSON file here. So yeah, it has a couple of data types. So the first one I stated here was a string. Yeah, that's a string. So it's represented by double quotes. So an example would be something like this, Emmanuel, in double quotes. It also has numbers like 1 and 2. It has boolean, used to represent true and false or true or false conditions. Null, which is used to define nullable values. Object, which is a set of name or key value pairs inserted between curly braces. The keys must always be a string and should be unique. So, and they should be separated by a comma. So it's more like JavaScript objects, but you're mandated to um, use strings as keys, and yeah, to use strings as keys. So you can add some other data type here if you wish, like um, maybe password. Yeah, do this, and it's going to be 1, 2, 3, 4, 5, 6, 7. Or better still, it could even be a normal number. So it doesn't restrict you from using numbers. Or it could be false, it could be true, it could be null, it could be any of those data types we've talked about. So we also have arrays, which like JavaScript is an ordered collection of values that begins with a left bracket and ends with a right bracket. The values are also separated by a comma like objects. So we see this is an array of objects. We can also have another object in here that probably has the same kind of properties. Something like this. So um, that's what that's what array is. It works basically the same way as that's defining it works the same way as in JavaScript. Then the syntax. The way data is represented is determined by JSON syntax rules. Some examples are that in JavaScript object, I said this, there are key value pairs. Data is separated with commas in both for both arrays and objects. We can use curly braces to represent objects. I said this also. Square brackets hold array. So I gave some examples. This is the example I gave. So this is a JSON file and this is a JSON object. So there are many other servers that are sending data, are probably sending JSON too, even though they can send XML or even HTML. They can also send JSON as representing data. So now, okay, form data. Now, handling forms in is about, like, forms are one of the, let's say, important um, HTML attributes in HTML entirely, and even in React. So handling forms is about how you handle the data when it changes value or gets submitted in HTML. Sorry, in or gets submitted. Then in HTML, form data is usually handled by the DOM. That's if for instance we have, okay, I have, if for instance we have HTML elements here. So if I declare a form here, the submission is handled by the 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 DOM itself. So every other thing is handled by the DOM. But in HTML, sorry, but in React, the form data is usually handled by components. So when data is handled by the components, all data is stored in the component states. You can control changes by adding event handlers in the unchanged attributes. We can use the use state to keep track of each input value and provide a single source of truth for the entire application. So let's say for instance we have a text field here which has we have a text field here which has an input attribute, and this text field is being rendered inside a form. If I go into this page, it's being rendered inside a form. This form is actually it's a form. The style form is okay is a div, but it can be changed to a form. So how you do render it or handle changes in React is, if you want a control component, we use the use state hook. As we say const, we say maybe username, and then set username, something like that, and equals to use state. I'll give it an initial value of an empty string. Then inside the text field, whatever it is, you can come here and say value is equals to username, and unchange is equals to, that's, unchange has an event, so we say set username e.target.value. So what this does is a two-way binding, and this text field now is considered as a controlled component. So every input, on every input the user or anything the user does, you're basically in control of it. So if you wanted to do validation of some sort, maybe of email, of password, your password should be, and change the DOM with respect to the user input state, you can do that with this type of form handling. Another method of form handling is using the ref hook. So that's the one I used here because I didn't have any validation to do, or I didn't have any need to continually observe the user's inputs. So that's this ref here. So if I open this form here, I open this form here, I just use ref hooks. So it's not controlled per se, but since I'm only using it when I need to submit the form, I'm not trying to monitor the user states or what he's putting inside. All I need to do is just, maybe after the user finish input, I clicks on submit, I just get body or what the user has put into the text field and I submit it. I don't need to do some validation. So that's one of the ways we handle forms, or those are two ways that are prevalently used in handling forms in React. I think some people prefer this way because it gives you more control over what the user is putting in, and if you totally need that, you even want that, or even need that, that's fine. But some people don't prefer this method because, especially when you don't need to observe, because it just unnecessarily renders the component over and over again. So, I mean, if you're not doing some sort of validation, you could just take this out of it and save the save the computer some re-rendering. So that's handling forms, and we submit forms like in HTML. When we say on submit, like in HTML, when we say on submit, we can also submit via and unsubmit attributes in components also. So sorry, I forget to state this. If I have a script tag here, I'm going to be able to manipulate the DOM. As if I say form is equals to document dot um, get element by tag name, or is form. I can be able to say form dot. I can be able to manipulate the form attribute from here, like what I defined earlier. I don't know. I don't think I explained it well, but what I defined earlier was that in HTML, forms are handled in the DOM, so you can actually manipulate the form attributes from here. You can actually observe anything you want to observe from here. Whereas in JavaScript, we manipulate it from the component is in charge of the state. The component housing the form is in charge of managing the state. So I think that should be it. So yeah, like I was saying, when we want to submit a form, we do this, or we can do the same thing. You can say form add event listener. You can say submit, and then we can have an event handler for it, and we can get all the form attributes. You can say form dot maybe get the items individually and submit them via an API if you have one. But in React, what is done is you specify an on submit attribute. I didn't use that here because I didn't like the functionality it was given. So you can specify it like this. This is camel case, and you can pass in the function like this, and then you can handle the submission. That's how we handle submissions in React. So giving some examples. So the next one is our promises, rather. So what are promises? Sorry. A promise is an object representing the eventual completion or failure of an asynchronous operation. So to better understand this, I created something here, this place. So normally, it came as a result of wanting to handle asynchronous operations. So in the previous days, when we want to handle asynchronous operation, we had a concept known as callbacks. So I just used a set timeout to simulate a long running operation for 3000 milliseconds, and then it then calls the function, does this callback with the data it got from whatever API, but it's just to simulate it. So, and then after that, I want to grab another set of information again. The same thing takes 3000 milliseconds, and so that's how it was being done. What happens is that your Node.js or your application waits until it retrieves this, and when it retrieves it, it then gives it back to whoever requested for it. There are a lot of concepts that go into it about event loop, callback queue, call stack, and all those things. But for simplicity, I'll just talk about this way that it was being done. So what happened there is I'll make a request to maybe google.com for something, and then I receive back a response. And if I wanted to do something with that response, maybe I wanted to make another request with that response, I will have to nest another callback inside here, make requests with callback too. that kind of thing. And if you're doing a lot of operation, this is when it can get pretty bad. That is, you keep on nesting and nesting and nesting, and you can imagine how that would be. So for simplicity, or rather, that's how it was being done. So if I run this, sorry. So if I run this, okay, sorry, load test. So I had a log here before request and after request. So both of them executed before even this was even logged. So what it gives me back, what the first one gives me back is the home directory, the version, the CPU architecture, the free memory, the CPU information, or the information I have about the CPU. Then after that, it then makes this request, then gives me a machine, which is undefined for some reason. But yeah, it gives me machine, it gives me temporary directory, total memory, my platform, my network interfaces, which are loopback, I think localhost IP. So those are the ways that, or that's the way it was being handled, and some technologies still use this way of handling APIs. Sorry, of handling requests or asynchronous operation. But the advent of promises came in. Now promises, we can return a new object or a new instance of a promise, as it is so called. Now this promise takes in a function that has a resolve and a reject. The resolve is called whenever it was successful, and the reject is called whenever it was unsuccessful. So to simulate something like that, let me comment this, or let me come back here. So okay, so yeah, it's the function receives two parameters, and then you then do your long running operation inside here. So what happens is whenever it finishes, you then call this resolve with the result you have. So in my case, I'm calling it with the same thing as before, but I'm just simulating maybe the API was not reachable with a random integer if it is 2, so just reject it. So that's just a simple simulation. The same thing here with making requests with promises, and then you do the same thing here. I did the same thing here with different information. So if I uncomment this line, what I have is, instead of nesting as in callbacks, I then have chaining. So what happens here is, after making this request, this one, there's now, I then chain it dot then, which then gives me the value or the result of what I got initially, and then it then logs it out. Now if I wanted to make another request based on that value, I will return it, and then the next then will then catch it and log it also. And that's the thing, we can continue logging with dot then, we can continue logging requests, sorry, we can continue chaining requests. So instead of using nesting as in callbacks use, we are using chaining. We can also catch, and we can also give a finally, that's it will run when everything has finished. So if I wanted to simulate this, I'll say test, sorry, node test.js. So now it does the same thing. It gives me my host name, my home directory, my version of, okay, now it simulated an unknown error code. That is when the random number was 3 this time. So let me it just simulates failure of an operation. So let me run it again. I don't think it should give the same thing. So yeah, it didn't give the same thing. That that random was just a simulated bad request or something. So after it's finished the first one, it then did the next one. My username, temporary directory, total memory, and the rest goes on. And then it then logged it is finished when, that's finally when it did it. And when it logged out an unknown error code, that was the reason. It logged the reason out. So yeah, that's how promises work. Promises clearly work on chaining, and then callbacks work on nesting. But next one is now async awaits, which I'll explain now. Um, Sorry, just give me a second. What was this? Sorry, please. Okay, okay. Um, Sorry about that. I guess that was literally a second. But so is async awaits now. Just to make sure this is recording. Okay, yes. So async awaits. So after promises that uses chaining, there was need for a better one, which was async await. An async function is a function declared with the async keyword, and the await is permitted only within it. The async and await keywords enable asynchronous promise-based behavior to be written in cleaner style, avoiding the need for to configure promise chains. So even chaining was a problem to some people, and then async await came into play. I have a so rather than using this now, it still uses promises. That's but not rather than using dot then, I have two functions here with async. So you can return a promise here as usual, or as in promise this thing as in promise based syntax. But the difference here is instead of using dot then, you then dot awaits. It's now awaits rather, and then it will then wait till this function has returned. When it then returns, logs the results, does the same thing with the next one, and logs the results. So if I just if I run that function till it does the first one and then it does the second one, so it does the same thing as in promises and callbacks, but its syntax is a lot cleaner and it's not as cumbersome as this one. So this is how async await helps us even in JavaScript. So I think that's it for async await. Then you've seen the equivalent. So the next thing to talk about is context API. So context API provides a way to pass data through the component tree without having to pass props down manually at every level in a typical React application. So now the thing is, if you see React application, properties are being passed down the tree from parent to child via properties, or props as it is called. But such uses can become cumbersome for certain types of props, even for themes that can be used even down to button level. Just imagine you had a huge application that needs that's a small component down the tree of the whole application needs the theme. You don't have to start passing down the theme property down level by level, even to components that won't even need them. So context provides a way for us to share values like this between components without having to explicitly pass a property at every level. So we'll see an example. So there's a concept of context provider and consumer. Now in class-based components, I think there's a normal syntax they use for. Okay, I have a. Okay, let me talk about context producer first. Talk about context producer. So I have a user context here. So this is a provider. So I declare a user context here, which uses React.create context with an empty object initially. So when I want to, so this is a user context provider. So this component is used to provide the value for the components that are going to be rendered inside here. So I'm using, whenever the children are being passed through, I'm going to use okay, I'm going to pass it down here to children so it will render as components here. So what happens is, in effect, that this is a provider and it provides a couple of values here. So resolve properties, request, set properties type, set type, reset inside here. And then a consumer would do something like this. It will be something like this. It probably that's in class-based components as then. It will be something like this consumer, and then it will then close. Then you then declare kind of something like this value, and then you start to render your properties here inside here. So I guess this is how it was declared in class-based components. But this is how it was used in class-based components. So if I had to use it, I would do something like I would maybe inside here I'll render maybe value dot something, because it's passing in the values from the consumer. But now in functional based components, all I need to do is just declare is okay, I used it in this register. It's just to say use context and pass in the user context as we created in, sorry for all these things. So inside here, so that's this user context. I'm exporting it. Just before that, I'm actually in this index.js, I'm actually rendering it as this user context provider. I'm wrapping the app component inside it so that it can be used by every component inside the application component. The thing is, if you don't do this, no other application inside they can use it. So so that what happens inside the user. So that's how to pass it down the component tree. So if I wanted to use it inside this, I have this register component here. So in this application I have two components here. So this is the register component I was talking about, and then this is the feed component. So this is register component, and I want to use the context values inside here. So the things I want to use are properties, types, requests, resets, and then set type. Okay, I'm not using this actually. So what happens is, whenever okay, just to simulate what happens in my application component, I have two. These are the two separate the feed and the register. The feed is this part here. So if I go to feed here, I still use the use context hook, and I pass the user context object I created in that user context here. I'm passing it down. So what happens is, I use the same. I'm using set properties, request, result, set type, and resets. So in other words, I can share properties between these two components without passing them as properties. And even maybe I have a nested child in here, so I can also use that use context inside here, and I'll still get the same properties. That's if I wanted to use those properties inside here also. So just to simulate what I'm talking about, if I click on this one now, everything changes here to update user, and then it then populates this first name, last name, username, email with their respective, will I say, values. That's what I'm doing here. When an item is clicked, I'm saying set properties from inside here to the item I spread it. So that's what's being done inside here. So if I click delete now, it's deleted. This one changes to create user because there's no user anymore. So if I wanted to create a new user, I would be like, okay, Emmanuel Stanley. the same thing. And if I say create user, it's going to create it, the user, immediately, and the feed component isn't going to is going to get updated immediately, because the feed component is also um, being notified about changes. They are using basically the same context. So I can also create new users. I can say not Chris, yeah, Christian, no, not Chris, Christian, no, Chris at gmail.com. So I can say create user, and the created user is created. I can also update the user's name. I can change his name to Jason and his username to Jason also. And also here I can change it to Jason Christian and click updates, and it changes immediately, almost immediately. So that's how I'm sharing states between these two. So that's the concept about state management. State management is a concept, even there are many other solutions out there. The concept used in big React applications to handle state across components to make it easier than passing down props level by level. So the next one is Redux, but because of how Redux was long, I decided to use another video to do it. So I'll use another video to do it and send it later. So if you have any questions for me, you can maybe ask me. Okay, thank you very much, Ma.